That somebody is typically the person who just sold you the tool. And then they may get to it at some point in the future, typically very far away future, because what you're doing is research and it's not very important for them. Or you use a tool like Papyrus. Open, highly customizable, and you build your solutions on top of that. Now, of course, for people on the other side, for the more users of Papyrus, there's an advantage to that. There's an advantage in that if you start using it in schools, people will start knowing about the tool. They'll learn more about what Papyrus can do, but also about UML and modeling in general, and we're going to end up having more modeling-aware software engineer, systems engineer going forward. Better tool, better trained people, better for the industry. If there are any questions at any time, don't hesitate. I like interactive, and I really don't like being off on a stage because I can barely see some people in the back. Let's talk about the UML. Long history UML. UML started in 1995. It was the unified method back then, not the unified modeling language. It was the three amigos, Boo, Trombau, and Jakobson, who got together, became part of Rational, and developed this unified method, and went to the OMG and said, hey, you know what, guys? There's tons of modeling languages like out there. Let's try to unify all of these. And the OMG said in 96, yeah, that's a good idea. Let's put out an RFP. And at that point, other companies, IBM, ObjectTime, iLogix, and a bunch of others got together and said, well, we can't let Rational drive all of this, so let's work all together on a proposal. They spent the whole year talking about it, and it finally got out with UML 1.1 in January 1997. Why UML 1.1? Anybody knows? Trivia. Well, Francis probably knows. Because UML 1.0 was a Rational product. In September of 1996, Rational said, well, you know what, this whole OMG thing is taking too long, we need to move forward. We're coming out with UML version 1.0. OMG was not all that happy about it, but they said, well, okay, fine. We're going to refine all of that, and we're coming out with 1.1. So the first OMG version of UML was 1.1. So that was 1997. For those who are wondering, UML 0.8 was 300 pages. UML 2.5, just released, close to 900 pages. However, lots more semantics, lots more stuff, and it needs a bit of simplification, but there's a working group on that. Going forward, people have realized, well, UML does have an extension mechanism. Most modeling tools in the past had what they called tagged values. Basically, you could define a tag on an element and put a bunch of values next to them. So it was a free-form kind of thing to indicate that an element was specialized in some way. That was formalized with UML profiles. And one of the profiles that is of interest to us here is MARTE. I already said what MARTE was all about. Another profile that is of interest here is SysML. SysML is also interesting in that SysML is a superset of a subset of UML. They decided to drop a few of the diagrams and add a few of their own and start talking about things like requirements and blocks and a whole bunch of things that make sense to system engineers, maybe not as much to software engineer. But it is important to mention it here because in embedded systems, very rarely do you have software that does not exist outside of a specific system. Very often you are going to have multiple embedded devices that are part of a larger system. Oops. Now the important part, this is why we're here, Papyrus is a sub-project of the modeling development tool at Eclipse, and it does reuse a whole bunch of different things. I'm not going to go through all of them. I'm probably missing a few, and the CAE guys are probably going, yeah, you're missing quite a lot. But this is just a global little thing, and that slide is actually a couple of years old anyway. And also, yes, there's a whole lot of abbreviations, all 3 letters. A lot of projects in Eclipse got 3 letters, like I heard at the talk preceding this one. So let's talk a bit about why we need Papyrus. There has been a shift in the software industry. It all started a long, long time ago, early 90s in my case, where, well, if we wanted to do some modeling, we had to build the stuff ourselves. We went out and we created all these modeling tools that were very, very proprietary, that had models that could not be shared by anybody else. In my case, what we were modeling were nuclear power stations. And we were modeling everything from how the reactor actually worked internally to the distribution of power outside of the system. Well, that works for a while, but of course industry does not stand still either. So people were looking at that and so seeing companies developing their own tools and say, wait a minute, there's money to be made. So starting in the beginning of the 90s, going forward, they're going, well, let's develop tools. And if you look 92 to probably 98, 99, you had an explosion of different modeling companies that came out, a whole bunch of different modeling tools. And for those who remember, those tools were expensive. Rational rows, we used to pay $4,000 for a seat, and that was for a general purpose tool. And Rose 3 was not all that useful. The code generation was crappy, and the software was rather buggy. And then you get tools that are much more specific, like Object Time Developer, which I'm going to talk a bit later on. Object Time Developer in 1998 sold for $25,000 a seat. But in 1998, we were in a big boom. 96, 98, we were in a big boom in telecom. People were buying the tools, dozens, 20 seats at a time without even thinking. Moving forward, what do we discover? Well, yeah, we can buy these tools, but the companies are starting to sell, are lowering the price because the economy is saying that we can't sustain a $25,000 tool with a number of developers. People aren't buying it anymore. So we're lowering the price, and we need to still do the maintenance. Well, yeah, we do have service contract, we do have maintenance contract, but this is costing us more and more and more. We're past the dot-com boom at this point. The bubble has burst. Companies are going, yeah, well, sure, we want to buy, but when we want something out of these companies, it's taking forever. What we really want is to be able to use the tool, be able to change them if we actually need to, be able to use them without all these problems talking to big companies. And that has led also to, it's about the same period that we've really started to see the growth of open source. We started moving from closed operating system to open operating system. We're starting to see more and more freeware and shareware coming out. Not that it didn't exist before, but the distribution was a lot more problematic. The internet was much more easily available. You could see a lot more of these tools going around. And a lot of companies are starting to think, well, let's go with open tools or open commercial tools. So open tools that are supported by commercial entities and as far as support is concerned. And that gives us the opportunity to organize and provide those industrial strength alternatives to proprietary tools. And that is what Papyrus is in the modeling space, in the UML modeling space. And of course, part of Polaris, needed to say that. If you want to hear more about this all open source tools in the industry, I would invite you to go see this talk here. Tomorrow morning, 11:45 in Argos. I don't exactly know where it is, but it's certainly around here someplace. And you're going to hear what Ericsson thinks about this move to open source. And they're very vocal about the need to go open. For those who don't know, Papyrus is coming out of incubation. Yay! It's late afternoon. I should have brought a lot of coffee to get everybody excited. It's going to be available with Luna. For those who don't know, that June 25th. Unless, of course, it's late. Oh, wait. This is Eclipse. Eclipse never releases late. I've been working with big companies, commercial companies for too long. I'm just used to late deliveries. You'll have to excuse me on that. Okay, embedded systems. So we've seen Papyrus. Let's move on to what is embedded system. So who works in embedded systems here? Who has worked in embedded systems? Quite a few, somewhat. I've worked a lot in embedded system, worked with a lot of embedded system companies. Typically, when you start talking about embedded system, you're talking about single-purpose systems. You're very often talking about specialized hardware and software. The software running on a very small system or sometimes very large system and is dedicated to do one thing and do it well. Embedded systems are things like controller, the electronic controllers in your car that control the gas mixture, that's one. When you make a phone call, it goes through a base station. Base station is running embedded software. It is typically limited in a few areas. Resources in general are limited. The amount of space you've got to store information, the amount of space you have to run your programs, the speed of the microprocessor, the number of cores that you've got, the interfaces that are available to you. You may or may not be running on a POSIX compliant OS, for example, so you have to do a lot more work with the interfaces. Those are all limitations that you encounter in an embedded system that you may or may not, but typically don't if you're developing database systems or systems for more general computers like the Mac here or PCs. Another very important point is timeliness of execution. In real-time systems, which a lot of embedded systems are, there is always a cost for missing deadlines. There can be soft real-time where the cost for missing deadline is, well, not that bad. So it takes 3 seconds for you to pick up a call, for the call to connect, as opposed to 1. Well, you're not going to die about that. If it takes 5 minutes and it's an emergency call, then yes, but so there's different costs. If the X-ray machine that is scanning you suddenly delivers a dose that is 100 times the dose for a normal X-ray, well, that's a bit of a problem. Nobody likes to cook on an X-ray table, right? So there are some costs of missing deadlines. And there are standards out there that have to be met. I've been working with telecom companies, telecom manufacturers for 12 years now. One of the biggest requirements for a telecom system is what they call a 5.9. They have to have 99.999% availability on their machines. That means that a telephone switch can be offline for 5 minutes a year. That is dependability. Your system is running during 365.25 day minus 5 minutes every year. So they have to be resilient. Very often they'll have switchover, failover systems. They'll have switchovers when you actually need to do maintenance. There's a whole bunch of thinking that goes around developing embedded systems. It's not simply writing a bunch of C code. It is a complete systems engineering approach and it is embedded, and it is software that is very, very tight. So how do we help doing that? And a lot of companies have been started to use UML in order to model their systems so that they can understand a lot of these things. They can start thinking about how to structure their system so that they can have those failovers, how they can actually validate the models of running the systems. State machine validations, for example, is one example of things that are being used. There's a whole bunch of also analysis that can be done on some of those models, from rate monotonic analysis to a whole bunch of other formal methods. I've already mentioned MARTE, and I'm going to talk about these a bit later. But the three profiles that are of interest is MARTE, UML-RT. It is not yet an approved profile by the OMG, but we're working on it. And it is a real-time version of UML. I'm going to talk about more about that. And SysML I already talked about a little bit. So let's start with MARTE. What is MARTE? And I hope I don't screw this up because one of the authors of the book is in the room. The pressure is on. It is an industry standard language. It is a domain-specific language for specifying and analyzing real-time system and embedded systems. And it refines the concept of UML for the real-time domain. And there is a very large and good book written here. The interesting part is that one of the authors of the book is actually one of the people who are in Papyrus. And the other one is the one who's writing UML-RT. So if you want the book, it's available in a whole bunch of places. Makes for a good read. So why do we have MARTE? One of the things about MARTE is that it provides accurate and precise modeling. It deals both with qualitative and quantitative, and also functional and non-functional characteristics of the real-time software. One thing that's very important in a lot of embedded applications is it defines time and temporal relationships. It has a concept of time embedded in the language, so you can actually start putting constraints on your UML model saying that this has to take this long to run and it cannot run any longer. And it also has this concept of allocation. So you can allocate hardware, software resources and actually keep track of them. Well, if you think about it, that looks a lot like what I was talking about when I was talking about embedded system a little bit earlier with regards to why is are embedded systems different. The MARTE spec was created at the OMG by the Pro-MARTE consortium, of which the CAE was an active part. And the book, Modeling Analysis of Real-Time and Embedded Systems with UML and MARTE, has examples in there that were actually done using Papyrus. So I would say very confidently that Papyrus is a reference for MARTE. Okay, another profile of interest is UML-RT. That one has a very long history. It started back mid-1990s with a book called Real-Time Object-Oriented Modeling, or ROOM. Some of you might have heard about the ROOM methodology. Anybody? Yeah, the usual suspects. ROOM was a domain-specific. Well, let me go through the history first. So ROOM was then implemented, again, mid-1990s, into a tool called ObjectTime Developer from a company called ObjectTime, and I was part of that company. And then ObjectTime got in the radar of Rational, and it got acquired by Rational and became Rational Rose RealTime. We actually built Rational Rose RealTime for Rational before they bought us. And that got into Rational Software Architect RealTime Edition. And if I were to ask you, where can you find Rational Software RealTime Edition? I'm sure you could go to the whole IBM site and not see any mention of it. And next step of evolution, let's move all of that onto Papyrus. Some people who are familiar with Eclipse will say, well, wait a minute, there's a Room implementation project in Eclipse, right? It's called eTrice. Yes, there is. But eTrice is not based on UML. eTrice has their own meta model, and they're going the Room to Eclipse-based projects going forward. It's a decent approach, but given the history of Room over the years, and the fact that one of the author of Room, Brian Selleck, has actually been part of this whole UML-RT approach and has been part of Rose RealTime and RSA-RT and has done a lot of work moving this forward and recognizes the the advantage of going the UML route, we probably prefer to go that way. So what is UML-RT? It is a UML-based DSML. Well, another one with MARTE. Yeah, but I think they can be used together, and I would really recommend that at some point we seriously consider putting all of these together so we can have a much better system. It has two aspects, an abstraction aspect and an automation aspect. From an abstraction point of view, it is foremost constraining UML. We do not want to expose users to the full UML spectrum. Too many things. We want to concentrate their view of developing their embedded system. And that means it's easier to learn and use. There are less concepts to keep track of. And Room has always had this, the model is the code paradigm. So although we will have code generation, we will also have a runtime layer with adaptability for platform languages and so forth. And the reason for that is we really believe that this is a one-way street. We do not want people to go and modify the generated code. We want to have everything done directly as part of the tool. And I'd better speed up a bit. And it is a proven approach. Just to give you an example, in the early 2000s, 80% of phone calls were going through telephone switches that had parts of their implementation done using Object-Time Developer. Our customers at the time were Ericsson, Alcatel, Lucent, Motorola. They were all on board for what we were doing. So UML-RT only has three major points, three major structures associated with it. It uses structured classifiers, which were used to be root actors or Rose RT, RSA-RT capsules. Basically, a classifier that holds both behavior and structure. It has protocols. Protocols is basically a collaboration of pairs of provided and required interfaces. So one port would have this protocol, so a provided and required interface, and a connecting port would have the same provided and required interface, but conjugated. You can use standard classes to carry data, and the ports as just talked about. So very simple concepts to use. From a behavior point of view, it's all done through state machines, hierarchical state machines that communicate through ports to other structured classes. It is coming soon to a Papyrus near you. So the company I work for is going to be building the runtime service layer and the transformation. And it's all going to go back into open source, which means that if you have different platforms, if you want to change the transformation, you will be free to do so, or to hire us to do that. SysML I talked about with the relationship with regards to how we see SysML at the front for the system engineer at the front of the process, developing the requirements, the constraints, and pushing that into UML. And that's basically it. So I got 2 minutes for questions. No questions? Well, if you want to know who's using Papyrus and what else is in Papyrus, the CA's got a booth right outside here, number 6. Go and talk to them. I'm sure they'll be happy to talk about pretty much everything. If you want to talk about UML-RT, embedded system, you can talk to me. I've been doing this for quite a while. And I'd like to thank all of you for attending this talk. Thank you.